Congratulations for making it to the last lesson in Math 2 class with Teacher Marian, Quarter 4, Module 3, which is Interpreting Percentiles. For this lesson, our main focus is to interpret percentiles. First, let us recall that the percentiles are the 99 score points which divide the distribution into 100 equal parts. It is used to characterize values according to the percentage below them. For example, the first percentile, or P1, separates the lowest 1% from the other 99%. The second percentile, or P2, separates the lowest 2% from the other 98%, and so on. Looking at these figures, we can see the relationship of quartiles, deciles, and percentiles. It can be observed that Q2, which is a median, lies in the same point where P50 and D5 is located. Therefore, we can say that in a distribution, D5, P50, and Q2 has an equal value. Moreover, the first decile is the 10th percentile. It means 10% of the data is less than or equal to the value of P10 or D1, and so on. On the other way around, we can say that the 9th decile is the 90th percentile. It means 10% of the data is greater than or equal to the value of P90 or D9, and so on. Make sure to understand this part since it is an important information needed in interpreting percentiles. Now, let us proceed to the first example. Find the 30th percentile of the scores obtained by 12 students in a summative test in Mathematics 10. This problem is an example of ungrouped data, so we will be using Mendenhall and Sinsich method in getting the value of P30. Step 1. Arrange the data in ascending order. Step 2. Find n, or the total number of elements. The value of our n here is 12. Step 3. Calculate the position of percentiles using the formula. Since we are looking for the 30th percentile, or P30, then the value of our k is 30. For n, the value is 12. Substitute the values and perform the operation. By doing so, the computed value of the position of P30 is 3.9. 3.9 becomes 4 after rounding to the nearest integer. This means 30th percentile is the fourth element of the data. So, P30 is equal to 39. In this problem, the value of our 30th percentile is 39. Now, let us have an illustration. Our 30th percentile can be found in this part of the distribution. Its value is 39. We all know that P30 separates the lowest 30% from the other 70%. 30% plus 70% is equal to 100%. So based on the illustration, we can interpret that 30% of the students got a score of less than or equal to 39. On the other way around, we can also say that 70% of the students got a score of greater than or equal to 39. Now, let us proceed to the second example. The value of P65 in the final test in advanced algebra is 35. How would you interpret the result? First, let us have an illustration. P65, or 65th percentile, lies in this part of a distribution. The value of the 65th percentile is 35. 65th percentile, or P65, separates the lowest 65% from the other 35%. This means that 65% of the students got the score of less than or equal to 35 in their final test in advanced algebra. On the other way around, we can also say that 35% of the students got the score of greater than or equal to 35 in their final test in advanced algebra. And that's all for this lesson, Interpreting Percentiles.
Maraming salamat sa panunood, mga kaalamat!